Okay, hello everybody. Welcome to our talk, Frontend Monoliths and Micro-Frontend. My name is Jonas Bandi. My colleague here is Wiehl. What are we going to talk about? So first I will do an introduction about the Frontend monolith and the characteristics of the Frontend monolith, and then how can we solve maybe the problems of the Frontend monolith with this mythical term Micro-Frontend. Then Dani will introduce the SCION Workbench. It's one approach how to solve the problems of the monolith. And then we will do a live coding session where we will actually use the SCION Workbench. So who in the room is actually old enough to remember that game? Okay, quite a lot. So what does this game have to do with development, specifically with web development? Well, there is this fact that in 2016, the average web page size passed the size of Doom. So if you are browsing a random page in the web, chances are big that you are downloading more code on your computer than you have to use when you were gaming Doom in the back in the times. And that's a good introduction to our topic, because our whole talk is about one fact: size does matter. Especially in web development. So if you are a backend developer, maybe size is not that important, because maybe you are building your fat jars or big ears, but you are probably not concerned all the time about it. But in web development, we know that the size of our assets are actually very important. So we are not putting big pictures into our web pages. We know that we have to put optimized images in our pages so that the user has a good experience. But this became even more important now with the rise of single-page applications, because with single-page applications, we are not delivering single pages, we are delivering whole applications into the browser, and the size of these applications is actually relevant now. So if we are looking into the concept of single-page applications, if we are browsing to a single-page application, then basically we are making from our browser to the server a request, the server serves us a document, but this document basically is empty. It's just a shell, typically. And this is used to deliver then the whole application into the browser by requesting more assets, specifically JavaScript bundles, then executing these JavaScript bundles, rendering on the client the screen, and then finally put this screen into the DOM so that the user can see it and he can start interacting with it. That's the concept of single-page applications. And in this regard, the size of the bundle of the JavaScript is important. There are two sides for this price, or two aspects of this price. First, there is the network cost that's similar to images that we are loading, but also for JavaScript, there is especially another cost. It's the cost of the CPU of the processing of this JavaScript. And this cost is not trivial. If you are looking at some studies from some developer advocates, for instance at Google, then this can make a major difference for the user experience. If you have a fast phone, then it can be significantly faster than if you are using a slow phone to deliver a big single-page application, or just a JavaScript-heavy application. So the guidelines from the Google guys, for instance, is that we should aim for a budget of 170 kilobytes for our initial JavaScript bundle to get a good user experience. So who is an Angular developer here? So maybe you realize that's quite difficult, because most of those 170 kilobytes will be already taken by Angular, so you will not have a lot of bytes for your own application here. So that's the picture I found recently on the internet, what's all about. So all these studies where they tell us to make a small JavaScript bundle is about money. So speed is money. That's the whole quintessence of that studies. So there are studies from Amazon or from Walmart which they tell us that even if they are getting a fraction of a second slower, they will lose money. And that's the reason why we should have small JavaScript bundles. One of the main reasons. But the question is, who in the room is actually working for Amazon or Walmart? So nobody. So maybe there is a big but. So that's the thing I am working mostly with, enterprise applications. And maybe in enterprise applications, it's not that important to have these small bundles. Only recently there has been a big debate on the internet where some people are actually attacking the Google guys, which were always telling about these small bundles or some stuff like that. Maybe it's not that important, especially for enterprise applications. In enterprise application, we usually have the network under control. It's a good network, and we have good processing power. So maybe it's not that important to make these small bundles. Maybe we can even live with 800K, 900K, 1 megabyte, and it's still a good enterprise application. Maybe that's also the reason why Angular is still relevant. So if Angular is not good in that regard, and some developer advocates, even from Google, are telling us Angular is a bad framework, but maybe it's not the only priority we can have, especially for enterprise applications. Maybe that's not the primary problem. But is there still a problem in enterprise application? Is size still relevant even for enterprise applications? Let's have a look. Let's have a look at the history of enterprise applications. So when we started, or when I started, maybe 15 years ago, we were building rich clients. And these were basically monolithic. Then there came client-server applications, and at the same time, there were some kind of tools created for making our front-end or our client applications modular. Especially, for instance, Eclipse RCP had a lot of concepts to deliver features in a modular way, with a plugin mechanism, OSGI, class loader separation, and stuff like that. In the recent years, we had the whole microservice hype trend, which is also about modularization of the backend. We try to make small chunks in the backend, small projects which are independent. Now what we see today is a lot of migrations from these rich client platforms where the future is very uncertain. Nobody knows where that is going, and everybody knows that the web is here to stay, and the web has a lot of advantages. And we are migrating a lot of rich client applications into the front end, into the web, basically. And what we get usually from these migration projects is we now know how we do microservices in the backend or how we do modularize the backend. So there's usually an improvement in the backend going on, but in the front end, there is usually the situation is much worse. One aspect of that is that the front end, the web, is not made for complex applications. It does miss some classical modularization concepts. And the other thing, basically, is that we neglected the web for a long time. And this was also put on the ThoughtWorks technology radar in 2017, that there is actually a problem in a lot of applications where we build these single large sprawling browser applications, which they call Frontend Monoliths. That's how we got to the monolith. So the real problem from the monolith is the coupling. So here we have the view of an application from a backend architect's perspective, and from that perspective, for a long time, we could neglect or treat the front end just as an implementation detail. That's HTML and JavaScript that some of the designers will do. But recently, where we delivered the whole rich clients into the browser with single-page application, the front end is not implementation detail anymore. So it's actually an important aspect of our application, and it should be considered as important for the whole architecture of the system as the backend. I might even be critical and say a lot of the backend modularization, microservices approaches that were successful were maybe a bit successful because a lot more work is done in the client. The whole orchestration is happening in the client, so you can slice the backend as clean as you can. So if you look at the goals of microservices, what are the goals? Basically, they are about enabling autonomy. Enabling autonomy means that we can have independent and parallel development of projects and teams. The teams don't have to synchronize. They don't have to talk to each other. They can deliver end-to-end and take full responsibility. In order to do that, the life cycles and the deployments have to be independent. The different features that I have deployed are not allowed to have side effect on each other, and they don't have to be coordinated. So one team can deliver several times a day, and another team can deliver 2 times a year, and this should be possible. The next point is the autonomous operation. So if the team should be independent, then also at runtime, the applications, the features have to be autonomous and isolated at runtime. It cannot be that if one team delivers a new release, then maybe another application will break. In order to guarantee that, we have to have hard runtime isolation. And finally, the technology agnosticism that we want to have. So each team should be able to decide which technology they want to use, which fits the best for their needs and their project. And this is especially important in the current front-end ecosystem, where we get a new front-end framework every 2 years, and everybody wants to use the newest technology. And you will never get these characteristics with the front-end monolith, because the front-end monolith basically prevents that. If the front end is a monolith, then you have to release and deploy together. Teams have to synchronize. They are not technology agnostic. If one team wants to upgrade Angular, the other teams also have to upgrade. And there is no runtime isolation. One team can make a break, something that breaks another feature, and everything is not working anymore. So actually, size does matter, even for the enterprise. So our goal is to break the monolith. For that, we need runtime isolation and development time isolation. Teams should not have side effects on each other at development time, and the deployed application should not have side effects on each other at runtime. How do we do that? So it's very simple. It's just 2 rules. The first rule is you do not build huge enterprise applications. Anybody knows the second rule? The second rule about enterprise applications is you do not build huge enterprise applications. But for me as a developer, this is not very helpful, because I'm asking how I am doing that. And then the answer is a bit more involved. You build micro-frontends, and if you Google micro-frontends, then you find something like, it is an architectural style where independently deliverable front-end applications are composed into a greater whole. And still, I don't know what to do. So that's the million-dollar question: how do we modularize our front ends? So first, we can look at the current frameworks. What are the current frameworks giving us? And the current frameworks are giving us mechanisms for build time modularization. So each of the current frameworks has this concept of code splitting and lazy loading, which allows us to incrementally load the application. So on the first page load, we just load some of the JavaScript which is needed for that first screen, and then on demand we load more modules or more code. Each of the frameworks can do that, but this gift doesn't address the problems of the monoliths that we have identified. Still one application which is compiled in one time, so the life cycles are not independent, and the runtime and at runtime they are not isolated. The other concept is libraries. That's typically NPM bundles today, so we can bundle some widgets, some components, or even whole features into a library version and develop it independently, and then build it together at runtime by declaring dependencies on other packages. But still, also this doesn't give us or doesn't address the problems of the monolith. It gives us the possibility to have parallel development, but the lifecycle and the runtime is still coupled. So with build time modularization, we do not address the core problems. Lifecycle releases are still coupled. We don't have isolation at runtime. So the next thing we can look at is runtime modularization. And for runtime modularization, we have to look at the web and how the web actually works. And one possibility to have runtime modularization is actually the link. The link is the core part of the web. It's a magical integration pattern. So we can have a shop here which sells a product, and he can have a link onto the specification which is provided by the producer of this product, and we can, as a user, can just jump from one page to another. And we can also use that to slice our application in smaller mini spas, which I call here. Of course, this has a lot of challenges. The biggest challenge is for this that the user should still have the impression that it is one application. So the styling and the usability and the look and feel should be coherent. If this is not the way we want to go, then, and we need actually a single page application, Then we can have an approach of having a micro-frontend which loads, a front-end which loads different micro-frontend, different applications on the same document. So we have different applications which are loaded into the same DOM. And for that, there is a demo. There is a framework which is called, so maybe I realized that. There is a framework called Single SPA, which is a meta framework on top of other frameworks. And for instance, in this demo here, I have a one page, and then I can actually load different applications on that DOM. So if I click here the Angular link, then we see Angular is loaded as a bundle, and Angular is rendered here. And if I click React, then a React application is loaded onto the DOM, and it is loaded here. If I switch back, it is fast again because it's already loaded. And if you look at it at runtime, then we see here in the body, we have different placeholders for the different applications. And if we switch the application, then the React application is present on the DOM, and if we switch back to Angular, then the Angular application is present on the DOM. So this is one of the flavors. In that case, each of the application brings its own dependencies, and is a complete bundle. The drawback of this approach here is that each of the application has to actually implement some hooks to be mounted on an existing DOM and then to be unmounted again. And the other thing, drawback, is they are not completely isolated. They still live on the same JavaScript context, on the same global context, and they can have side effects on each other. The next step, if we actually want to address that, is to have iframes. Iframes give us complete isolation. And well, iframes don't have the best reputation, thank you. But we will see with the SCION Workbench, we can actually do a lot with iframes. So the takeaway here is there is no silver bullet for front-end modularization. You have to implement one way that fits your project, and you have to choose which way. And if we are talking about silver bullets, I want to mention one last thing. This is web components. Web components often are mentioned as the silver bullet, which solves these problems. Web components even goes further and says, okay, it allows to have this kind of front-end composition where you just deliver independent, autonomous components, and whoever wants to consume them, if it is an Angular application or a React application or a Vue application, you can just consume them, and it's just an implementation detail if the component is implemented itself in Angular, Vue, or something else. In reality, this poses a lot of problem. For instance, if the component should be autonomous, then size really does matter again, because if you have for each dropdown, each input component, and its own version of React or Vue or Angular to implement that, then you quickly end up with a situation where your bundle really gets really big. The second drawback of web components is that they still do not isolation on the JavaScript side. They do isolation on the styling side with the shadow DOM, but JavaScript, they still live on the global context, and they can have side effects on each other. And the last drawback is, because of this isolation, they are registered globally. So if we look how a component is registered, it's with this global variable custom elements, and then you can define a custom element or a web component, and this means that a given component can only be present on a DOM in one version. You cannot have different versions of the same component on the same application, which is quite a major drawback, which then causes team to coordinate again if they want to use the same component. So web components are not the real solution. They just give us a simple way to consume, embed components, and they give us sometimes parallel development, but they do not give us the independent lifecycle and the runtime isolation. So these are also not a solution. So Dani will give us an overview how the SCION Workbench actually addresses this thing.
Thank you, Jonas, for this insight on how to do micro-frontends. My name is Daniel. I work for mtrail at SBB. I'm the technical lead of the open source project SCION Workbench, and I would like to take this opportunity to say thank you to SBB and mtrail for supporting open source software and making SCION Workbench possible in the first place. So back at SBB, in the system which we're developing, some people think that in the near future, across the next years, there will be 40 teams which develop the system in parallel. 40 teams, that's a huge number. And most of the teams are doing completely different stuff. So it's kind of complicated to stick them all together to the same release cycle, or to enforce them to use the same frameworks, libraries, or languages. So we need kind of separation so that each team can choose their right technology which solves their problems best. And that it should be possible that whenever they have the need to go into production, that they can go into production with their feature. We believe that it's best to have feature teams with one feature team responsible for a single feature. So the feature team is full stack staffed, so it develops its feature from the database to the UI. But yeah, okay, now we have 40 teams, 40 UIs. That's not the way to go. The user doesn't want to handle 40 applications. So we need kind of a thing that integrates all those UIs. Nowadays, we have some amazing frameworks like Angular or React, which which allows us to do beautiful software web applications. And we have web components, but as Jonas already told, web components, they also have the limitation, and they're not sought to run whole parts of application inside the web component. So we had to look for a solution to address this problem, and we came up with SCION Workbench. The idea behind SCION Workbench is quite simple, so it should provide some way to integrate all those 40 applications into a single application. Then it should be possible for every team to use whatever framework they need best to solve best their problems. And they should be able to deliver whenever they like to. And the platform should provide some way to interact between those applications without having eager coupling between the applications. So, but to understand how we came to the Workbench Application Platform, I would like to take you on a journey and show you how all those stuff began. 1 year ago, we started developing one of these 40 applications. It's a business application which mainly consists of forms, tables, and lists. We knew that we had the requirement to show data, to open multiple data records at the same time. And the most pragmatic way to do that is to use tabs. But a way more practical way would be to show the tabs side by side so that the user can compare the contents. And when that is already possible, why not show content below or above? So we did that, and that's actually the date of birth, the birth of the SCION Workbench, which allows the user to have views and drag and place them, arrange them flexible via drag and drop in a view grid. But soon we realized, oh, the performance is bad. Why is that? Now we have a lot of content on the screen, but most of the content not even visible to the user. So we helped Angular a little bit, and we took all the invisible parts, the inactive views, out of the DOM and the Angular component tree. And everything was fine again. Then the number of entities grew, and we need kind of something of entry points into the application. If you're familiar with the idea of Visual Studio Code, you know that activities are entry points with one activity can be active at a single time. So now we have a grid, and we have the entry points. But after you reloaded the page, everything was gone because everything was in memory. So. But actually, the user in the web is used to a URL which reflects the current representation which he sees on the screen. So we gave every view a view outlet which allowed us to control the content of every view with its URL. And suddenly we had back the full power of Angular routing, because now every view could do lazy loading, could use guards, or use resolvers, and much more. Then some other interaction elements came to the workbench, like pop-ups, message boxes, which can be view model or application model, and notifications. And recently, we added view protections, which are only visible which are stick to a view, and when the view is active, those actions are available to you, yeah. So that's pretty much it. That's what the workbench is all about. It provides you a lightweight application frame to build multi-view Angular application. It's important to note that the workbench only goes to the view level. So it's up to you. So you can choose whatever widget library you want to populate the views. Also with routing. Because the workbench is a first-level Angular citizen, and with routing at its heart, you feel instantly comfortable with it because everything is about routes. But in the beginning, I told you about those 40 applications, and that we want to integrate those applications into one single application. So how are we doing that? For that, here helps us the Workbench Application Platform, which is actually an extension to the Workbench. The platform, here on the screen you see two applications, one written in Angular and the other in React. So the platform provides us a sandbox per application. She gives us a total scripting context and a shadow DOM. So it's possible to use whatever library you need to solve your problems best. Then the integration is solely based on the URL. This allows us to integrate any web application without the need for adapting it. Then the platform introduced the concept of an application manifest. So every application has to say what its capabilities are and what she intends to do. Capability is some kind of functionality which an application provides as a micro-frontend for other applications to integrate. And an intent is something which an application intends to do. Then the platform provides us with a way for the interaction, and that's the most important thing. So when application 1 wants to do something which she does not have the capability itself, then she issues an intent to the host application where the Workbench application platform is installed, and that's like an intent router, because the host application knows all the manifests, it knows all the capabilities available in the system. So if application A intends to do something, the host application knows which other application provides a capability and redirects the intent to the respective application and invokes its entry point. That's a big picture of the Workbench application platform. So let's have some deeper look into such an interaction example. Here we have manifest of application 1, and she intends to open a view, and a view which is showing a person. But this application 1, she has no idea about persons, and she also doesn't know which other application does provide the capability of presenting you a person. Here you see the qualifier, and the qualifier is used for logical addressing. You simply say, the application simply say in its intent what she wants to do. And here she says, I want to show a person of that specific ID. And then she uses, for instance, she puts a link on the screen, and when the user clicks the screen, here you see, then the intent, the effective intent is issued. So now this says that when the user clicks this link, this application likes to show a person with the ID 5. And somewhere in the system there's another application which provides a capability that fulfills that intent. And when the platform invokes this capability, here you see a path, then this path is invoked by the platform and shown as a micro-frontend. And the most important thing here is that application 1 has no idea that application 2 provides that intent. And that's pretty much it. So the Workbench application platform, she allows us implementing in a micro-frontend architecture and to implement different web applications. On the left-hand side, you see here a screenshot from our demo application on GitHub. the areas with the green boxes, that's one application, and with the red application, that's another application. And on the right-hand side, a sample setup, you have a host application with the workbench and the platform installed. The workbench provides you with the view grid, and the platform allows integrating micro-frontend. And then for the micro-frontend, you actually have to do nothing, unless you want to interact with the platform, meaning issue an intent. Then you can integrate a guest API, which is written in TypeScript, so it's framework-agnostic, can be used by any web framework. Yeah, that's pretty much it. So let's have some fun and do some life hacking to see the Workbench Application Platform in action. What are we going to do? We are going to create a contacts application which allows us to manage our contacts. So basically, it features the following things. She allows us to see our contacts, allows to view a contact or edit a contact, and also to create new contacts. But we do not want to do simply a single-page application. We want us to integrate into a host application. So what do we have to do? We have to provide an application manifest where we specify that all those three things are our capabilities, and that our application can invoke those capabilities and integrate them into their applications. And of course, we need to develop a host application with the workbench and the platform in it that allows us to do that. So I head over to IntelliJ and do some coding. We have prepared three applications. There's the contact application and the contact application. The host application we just created with Angular CLI, and you see it's a regular hello world from Angular if you do ng new in the CLI. So we also downloaded the required modules from npm registry. That's the SCION Workbench and the Workbench Application Platform. So now we are going to include those modules in the application module. So I import here the relevant stuff. That's the workbench, and that's the Workbench Application Platform. Then I go into the root component and delete the Angular boilerplate and place here the workbench, which provides me the application frame. So when the page reloads, we now see an empty application frame, which nothing does yet. So let's head over to the contact application and provide our first capability. And that's the capability to list our persons. So in this application here, we have the contact list, which we're going to implement soon. But first, we will add some route to the application routing module to make it available to the outside of our application. So that's normal Angular stuff I'm doing here. I create a route for that contact list component. So under contacts, those component is shown. And this component here, actually, it does nothing yet. Oh yeah, sorry, of course. So at the left-hand side, you see nothing. This is the HTML, and on the right-hand side is the controller. So I'm going to inject here the contact service. That's a service which allows us to get our contacts. And here I do an unordered list where I iterate over our contacts, which are provided by contact service. I get an observable, and then I use async pipe of Angular to do the subscription. And then I simply print out the first name and the last name. There we go. So this is not good. Sorry? Oh, thank you very much. Thank you very much. Yeah, fantastic. So now I open the contact list. On the slash contacts, you see my contacts. So, but now let's integrate this list into this host application, and we want to provide an entry point in the form of an activity. So what do I have to do is first I have to create a manifest. So here under assets in the contacts application, I create a new file, manifest.json, And in here, I fill in the boilerplate. There we go. And you see, here's the name of my application and an empty section for my capabilities and intents. And now let's formulate our first capability, and that capability is to provide the context list. You can see here, the type is a capability, and when somebody invokes this capability, this path here is invoked. That's our context list we just saw here. So, but the host application doesn't even know that we exist. So first we have to register our application in the host application. So I open the application module of the host application, and here I register our contacts application. And it's basically nothing more than the URL to this JSON file we created just before. And now here in the host application, you see we have an activity with our contacts list. So let's go on and put in here a link so that we can view or edit a contact. And again, we are doing the same thing as before. In the contact application, we first provide a route to that component, which allows us to see our contact. So in here, that's the route. On the /contacts, we expect that an ID is given, that is the ID for the contact, and then the contact component is opened. The contact component itself, it's pretty boring. It's I already prepared it. It's a form which contains several input fields for the person, and in the controller itself, here we have the current route injected. We get the ID parameter out of it, and with the contact service, we then load the contact which is bound to the form. So let's have a look at this. If I press 5, so that's the component. That's the fifth person we are looking, Robbie Bannon. So now let's integrate this into our application. So actually, this is the first time we are interacting then with the platform. So if I click here, it's an interaction. So I need the guest API to interact with the host application. So let's do that. I go to the app module of the contacts application here, Workbench Application Module. There we go. I import the module, the guest API, and so now I'm able to interact with the platform. Then what is missing? Yeah, we have to provide a capability to show the view. So here in our manifesto, we enter the next capability. That's a view capability, which allows us to show some personal data of a contact. And if somebody invokes this capability by issuing intent, this micro-frontend at /contact/ID is shown. So it's exactly the micro-frontend we are having here. So now we're already done. We are going into in the list component, we have to remove this and put a router, a link around it, wrap it with a link. And when the user clicks this link, we say that we want to issue that intent. So when the user clicks this, here open contact, this first contact, this link, then this intent is issued. And that's exactly the same intent we have here. You see, we expect here in our capability entity contact/ID and put it to the right. And here we are issuing an intent to our own capability. So this is the relevant parts. So now let's go. Implicit intent. It's provided by myself. Yeah, I do not have to define intent, because for all the capabilities which I provide myself, I have implicit intents. So now you see we have here the router link, and if I click a person, that view is now, that view now is integrated. So the time. So let's change the view tab. Let's put in there some more meaningful information, like the first name and the last name. So I open the contact view, and I inject here the workbench view, like this. And here I get the contact, and I set the title as contact first name, last name, something like this. So if I go over to the application, you now see we have the name here of the person. And actually here we are already seeing pretty much a lot. So if I make split screen, now here all those things, all those micro-frontends are provided by the very same application. But actually they're running multiple instances of this application. So this is one application instance running, that's another one, and that's another one. So there's one thing missing, and namely to create a new contact. So let's change that. First, again, we define a route. It's a normal angular route, and we provide that route. We say the path is contact/new, then please show me the contact new component. And this looks like this. And this component we want to provide as a pop-up to create new persons. So I go into my manifest, and here I declare a further capability, namely a pop-up capability, which says when somebody wants to use this capability, a pop-up is opened and shows the content of contact/new. That's this screen here. So now we have the capability. One last thing is missing. We want to place a button here in the host application of the activity. So how can we do that? I go to the contact list, into the HTML file, and here we have the unordered list we created at the very beginning, and here I define a pop-up action. So the magic thing actually is done with this directive here, which creates a button in the host application in the current activity. And you see, when the user clicks this button, this intent is issued. So the intent entity contact action create, this intent is issued. And if we have a look at our manifest, the capability we just declared, it's exactly that qualifier which this pop-up expects. So with the qualifier, actually that's only a dictionary of key value pairs, and you're completely free how to define that. It's completely up to us, up to you. So now in the application, you see now we have here a button, and if I click this button, the pop-up opens, and now I create a new contact Jonas. He lives somewhere, and now you see the details of this person. That's the edit view we created in the middle of the session. So yeah, that's pretty much all.
Okay,
what do you think?
That's very great. But let's take it one notch up. I have an idea for a great application, but I want to write it in React.
Yeah, go on.
So let's have a look. So we already prepared that. So you have seen there is another app here, which is my jokes app, and this one is already running on port 3000. Sorry. And this is just a standard create React app, so that's the pendant of the Angular CLI. It's a boilerplate React application. So my idea of this application is the following. I go in and I say, I want to provide you with a joke. Oops, it's dark in here. Just a moment. So I'm fetching a joke from this great API here, and I'm loading that joke. When the component is loaded, then I don't want you to display something out learning React, because we already can do that, and we just display the joke when the component is rendered. Here, when we save that and switch back to our application, we see there is a joke coming. And we can reload the application, we get a new joke. Isn't that a great application?
Yeah, that's great. So
maybe your workbench is a bit boring, so we could integrate that into the workbench. Yeah. How would we do that?
Yeah, first the workbench must know that you exist at all.
Ah, yes, I see. So I have to provide this manifest where I tell you what I can do.
Yes.
So let's go in, and I provide a new file. So something like that. I can choose whatever I want. And then I put in here this description of my application.
Yeah, and you say what your capabilities, what you want to provide.
Here correctly. I can provide my capabilities. Okay, my capability is actually to show a joke. Let's see. So here, thank you. So here I say I provide a view which shows a joke, and here are the properties of that joke. Actually, we took out the router, so the path is just an empty path here, basically, which we can integrate into the workbench. So can you integrate it now?
Yeah, of course. Now you provide a capability in a manifest. So we have to go to the host application, into the app module, and register your application as a further application. So here we also registered the context application, and now we also we are registering. Oh, that's the wrong keyboard. What happened? There we go. Joke app. Sorry, it's here. So, no. There we go. So that's your URL, and yeah, now you're in the platform, but we have to interact with you. So we have to open you.
Let's do probably in the form. The form is quite boring, so we could just show a link from there.
Yeah. Okay. I open the form. The contact form, the HTML, and here we can place a button like this. It's a link, and when I click this link, entity joke is invoked, and yeah, somebody will enter. I hope it's going to be your application.
Don't you have to declare the intent?
Oh, thank you so much. Of course, now I go to another application, so I also have to declare an intent. So I open my manifest, and in the intent section here, which is empty, until now, I say that I want to open your view. That's exactly the qualifier you provided. Yeah. So here now we have a button, and if I click this button, what did we do wrong? Yeah, of course. Yeah, I did. So that's you. In the contacts app, entity joke. That was your thing, wasn't it? SCION entity joke. So let's give it another try. So actually it should work. Something is wrong. It's a little typo, but I think we're running out of time. How much time we have?
1.5 minutes.
1.5 minutes. So
that's manifest.
Okay, that's your manifest. Manifest is kind of JSON. Here you say entity joke. Everything looks good. And here, type view, entity joke. It's all right as well. So let's install the dev tools. Maybe they help us in analyzing the issue we currently have. So the dev tools is simply a normal application, which I install in the host application. So I register here the dev tools like this. So, and now I get here the dev tools, and here I see all the application part of this application. Oh, I don't see your application. Probably the URL is wrong. So we say here localhost 3000 manifest. Oh, it's a typo. Is it a typo? Where do you provide your manifest?
Open the public.
Oh, SCION, that's a problem.
No, that's the wrong modified. Where did I put it into script? To script.
Yeah.
So just put it up here. Thank you.
Where here?
Yeah.
Thank you so much.
So, and now refresh.
So, reload that. Ah, the
And
joke
now
app
we
is
see the
here.
joke app
Oh,
there.
great. So,
And now the link will work.
and now, yeah, the link works. Oh, great. Cool. So, actually, we also planned to do, go back into our application. 30 seconds. Is that okay for you?
Oh, time is over.
Time is over. Okay.
So if anybody wants to be interested, so the demo would go on. We would open the contact form again from the React app and have this pop on top of the React application. But time is over, sorry.
Yeah. So one last thing. First, thank you all for coming and for your interest. And the workbench is not responsive yet and only is optimized for Google Chrome. So do not open it on your mobile phone. It will not work. But we will address this year. So by the end of the year, it shall run on your mobile. So that was all. Thank you so much. If you have questions, come to us.
So the whole demo in a working version is in the GitHub repository.